Well, thanks for coming. This is like the very last session, so anyone, I know you're diehards if you can make it to this point. Thank you very much. I'm Dan Bandera, president of the OSGi Alliance, and I have two of my colleagues from the OSGi Alliance and also from Adobe Research, Carsten Ziegeler and David Bosschaert. David is our co-chair of the Enterprise Expert Group, and Carsten is on our board of directors, also very active in the Enterprise Expert Group and other expert groups as well. Uh, every year, these guys do a great job of summarizing some of the new things in OSGi, and it's interesting because what was in Release 7, which was just released, and now they're going to give you a view ahead of what's up next. So I really appreciate you coming here today. There is a wrap-up session in the main theater. I don't know if you guys have been to it before, but it's kind of fun. So I'd encourage you to go there afterward. And in addition, I've been nagging and nagging and nagging, so you probably heard me say this 10 times before, but T-shirts, socks. We just don't have enough room in our luggage to take them all back. So thank you very much, and I'm going to turn it over to Carsten and David.
Okay, thanks then. You said socks with O, right? Not with a U. Correct. Good. Just to make sure. Okay, yes. Yeah, welcome to our session. And Dan did already the introduction. So over there we have David and I'm Carsten. And we are going to talk a little bit about some stuff we did in R7 and then continue with some new cool stuff we more or less just started this year for the next release, which will be release 8. Okay, but before going into that, I guess it makes sense for those who are not directly involved in the specification process at the Alliance. It makes sense to briefly give you an understanding of how it usually works, how we create specifications. So it usually starts with gathering requirements. Someone has a cool idea, oh, we could work on this or that topic, and then we get together and drink some beers and come up with some very useful requirements and create the first document, which is the RFP document, basically listing the problem domain, requirements, use cases, all these things. And it's more or less not technical in there. It's really just figuring out what the specification is about in the end. Once we have that done, there's a vote, it gets approved, and we then start with this technical work, the RFC, or technical specification, where some people start figuring out how to design the API and all of these things. And once that is moved a little bit along, so there is some substantial stuff to talk about, the reference implementation is started, which proves that this, whatever is specified, is really implementable. Because sometimes you come up with really great ideas and then you try to implement it and figure out, oh, that doesn't work, right? It's not implementable, or way too difficult to do. And then the other thing that is later on created is the CT, so it's a suite of test cases that verify that the reference implementation is implementing what is the specification, which makes sense. And then at the end, these three, and then someone takes the technical document, the RFC, and creates a spec chapter in our OSGi specifications. And then this spec chapter, the test suite, and the reference implementation make up the final specification that we release. Okay, so that's just to give you the idea. And let's start with the first topic, which is something we did as part of R7. So it's available, it's released, it works very well. That's the CDI integration. It's a CDI extender, to be more correct, and it basically connects in some way CDI with OSGi. So you can write your services using normal CDI annotations and then mechanisms and mix and match them with OSGi services. It supports basically all the CDI annotation processing and extensions and all of these things, and it's very nice. But on the other hand, you could ask why did we do this? Because in OSGi, we already specify declarative services as a nice way of implementing services. So why is there the need for something else? And basically, more or less, the main use cases, I guess, is that people have existing code using CDI and you want to use it in an OSGi environment, or you want to take advantage of all these additional annotation processing that CDI provides. And we see some small examples there. And I think there was a CDI talk this morning, right? It was a full-blown information about CDI from Ray. And then, yeah, the other thing is with declarative services, you can't have private services, which are just private for your bundle. With CDI, you can do that with the CDI beans if you have a use for that. Just briefly, the OSGi service model has as a basics the service registry, right, where you can register services and find them and get them from the registry. There are different scopes, singleton or per bundle or prototype. And the nice thing about the service registry, that's basically decoupling the registry itself from the model that you use to implement the services. So you can use declarative services to implement your services. You can use CDI, you can use whatever you want, and they all use the service registry, which guarantees that these services can work together regardless of the, let's say, component container used to implement these things. So let's see, and this is really just a brief, very quick run through how developing services with CDI looks like. And I guess there are better ways maybe than what we've come up here. So if you want to implement a service, this game controller service over here with using CDI technology, you basically stick some annotations on top of the class. It's maybe a good idea to use a bean annotation, which basically marks this class as a bean class for CDI. With a service annotation, you specify which service you want to what service you want to register in the service registry, and then you can use additional annotations. So that's, I guess, straightforward to do that. If you want to use other services, you can use field injection, for example, and use the add inject. That's the annotation from CDI, together with the add reference, which is an OSGi annotation, and that basically tells that this field gets injected with an OSGi service. If you just want to inject CDI beans, you just use inject as you would normally do with CDI. Again, straightforward. And this is my what it's called DBA slide, the death by annotation slide, where you can just use a lot of annotations together to reach a very simple goal. For example, if you want to have register your service with some service properties in the service registry, you define an annotation which holds the properties that you want to use in the service registry, and then you stick that annotation on top of the class. You see that's, I call it context config, that contains these two properties, and then context config is used up there at the class level, and that basically tells that this service is registered with these two properties in the service registry. That's one way of doing it, but again, you need to get used to it and learn using annotations. But in the end, CDI, that's all about using 300 different annotations together and stack them, and then you have some magic application running. Just as a comparison, or I mean, it's maybe not a fair comparison, but just give you the idea how that compares to declarative services. So if you want to declare a service in CDI, you use this add service add bean. You might not need to use add bean, but I would suggest to do so. In DS, it's a component annotation. References are similar, except that you need two annotations in CDI to get an OSGi service. With DS, it's just one. And again, if you want to do this property stuff, it's a little bit more annotations on the CDI side, but it's basically the same. And you can choose whatever you want to implement your services. If you want to use it, there's the implementation in the Aries, Apache Aries project, and you need latest BND tooling for your project to pick up these annotations at build time. And we have some references at the end of the slides where you can find projects that as example projects. Sorry. All right, and with that we go to the new stuff that we are doing, the R8. And stop it.
Thanks, Carsten. So yes, so CDI is something that we did already in R7, which was finished earlier this year. And we're working on some R8 specs now. And we're going to give you an overview of the new topics that we're looking at. So one of the new areas that we're looking at is messaging. Messaging API for OSGi, and this is done in RFP 192. So this is just a requirements document at the moment, and Mark, who's at the back there, is quite involved in this one. So the messaging RFP is about creating a remote asynchronous messaging API for OSGi that supports, publish and subscribe and point-to-point messaging. And it also supports something like qualities of services and intents. So it can really kind of work with, advanced features of an implementation without dragging those details into the specification. Because at the same time, the idea is that this RFP has to be lightweight so that it also applies to the IoT expert group. And this is one thing that I think is worth mentioning. In OSGi, we have a bunch of different expert groups. We have the enterprise expert group, but we also have the core platform expert group and the IoT expert group. In the past, we had other ones like residential and vehicle. And the interesting thing is that many of the specs, even though they're developed in one place, they're also usable in another place. So this one, whereas messaging is typically an enterprise topic, the IoT world needs this as well, and basically if we made this too heavyweight, then the IoT expert group would simply say, oh, we can't use this because it doesn't run on our, embedded devices. So there's not a lot of detail on this one, because it's just an RFP. Hopefully within the next couple of weeks we'll have an RFC. Mark is, nodding. Good. We'll have a link at the end of the presentation where you can check if the RFC arrives. And the next topic is Connect.
Oh, it's me again. Right, yes. The next topic is what we call OSGi Connect, and we are basically rebooting an old idea that already came up a couple of years ago. But the specification we are now working on is slightly different than what has been discussed several years ago. And it basically, with OSGi Connect, you can connect the OSGi framework with, let's say, stuff from the outside. Outside meaning things that are already on the class path. It might be JPMS modules. Today I gave a demonstration of how to combine OSGi with Spring. So you have Spring Boot on your normal class path, and then you can use Spring services in OSGi, and the other way around. So these are some use cases, or for any other things that are already on your class path, and you just want to make it available to OSGi. So that's very, very useful. This specification is already in the RFC phase, and there are already prototypes for the Equinox framework and the Apache Felix framework to implement what is already there. So that's already progressed some way, I would say. It's very, very interesting, again, as you can connect two worlds into one and then benefit from all the advantages of OSGi, but still you can reuse stuff using other Java frameworks. And with that, we get to the next specification, which is David again, right. Condition service.
The condition service. So this has been a recurring topic in OSGi. OSGi is a highly dynamic and asynchronous system. And when you build an application using OSGi, when is it ready? When do you want to tell your users, you can use it now, right? So there has been discussions in many different platforms about the ready service, the thing that is telling you, yes, your system is ready. Now, the problem with the ready service always was that, what is ready to you may not be ready to someone else. Because with OSGi, it's highly component-based, your component might be ready, but then you may not notice, but in the future your component is used in a bigger system that has another component. So while you think you're ready, the entire system is not yet ready. So this basically kind of evolves into something called the condition service. And the condition service is a very, very simple concept. It basically means that there's this service interface condition which can be registered by someone, doesn't say who, to indicate that this condition is ready. Now, there can be many, many of these condition services, so you can nest them in as many levels as you like. And this can be totally application specific. So you don't have to know how your system is becoming ready. You can just say, the condition with this name is ready. And then the next level can basically take that on, and maybe it can add another condition at a higher level readiness. So this is very, very easy to use. The condition service itself does not contain any methods. It's just a service that is registered with a property with the name of the condition. So let's say I'm writing a DS component, and I want that component to only appear, maybe the component prints the word ready on the screen or something like that. I only want that component to appear when my condition is there. So the only thing you need to do for that is have a reference in your DS component that is condition ready, and then as the target of the reference you need to name the condition that you wait for. So that's as simple as it is to use this. There is some discussion about changing DS itself to have every component implicitly depend on a condition. And by default, that would be the true condition. So the idea there is that the OSGi framework registers a condition with the name true, and that condition is always there. And every DS component would implicitly depend on that condition. And what you can then do is, at runtime with configuration, or not necessarily at runtime, but with configuration without changing the code, you can change the condition it needs to wait for. So with that, you can say an existing DS component needs to be delayed until a named condition is ready, and that would be a purely configuration effort. So that's kind of still under discussion as far as I know. The example at the top, that's kind of pretty simple, and it's also a very, very easy way to use it if you have a chance to modify your code. And then registering a condition, obviously it's as simple as registering a service, so you can just use the service registration mechanisms, DS, or just the framework API or CDI to register these services. But the condition specification also contains a declarative way of generating condition services using configuration. So here in this example, I hope it's not too small. There is a configuration called system ready, and this system ready registers a service called application.ready, and it only registers that condition if all of the conditions match right here. So there is a service of type servlet with a service property that says role equals main, and there is a database connection. So that has to all exist. And then there's a list of things that cannot exist for this ready condition to be there, and that's that there is a loading servlet. So in many systems you have, like if they take some time to start up, you might have a loading servlet that kind of shows some page when you access it, we're still loading. So while that one is still there, and the application is not ready, but if that one's gone and the other services are there, the condition service is registered. Ray.
Can I just ask you to clarify where the JSON comes from?
Okay. Good point. So the JSON is part of the configurator specification, which defines a standard way of describing OSGi configuration. So this is a new R7, thank you Ray, a new R7 specification that is out there ready to use, and it basically, this is a way you describe a configuration using that system, that specification. Okay, I'm moving on to another RFC called features, OSGi features. And so this is a totally different topic. OSGi features are basically a way to work with entities that are larger than bundles you know, individual bundles are great, but once you have a system that has a lot of bundles, it kind of becomes hard to manage. Now, unfortunately, I had a more detailed session about this morning, so the order's the wrong way around. But basically, sometimes you need a way to work with large amount of bundles in a more chunky manner. And maybe besides just bundles, you might have configuration, maybe specified using this configurator syntax. You might have other data that is not OSGi, that is like specific to your application. So OSGi features basically provide a design artifact, and which can be taken into runtime as well. But this design artifact allows you to bundle these things together so that they become easier to reason with and easier to work with as well, because you just take a bunch of, you know, these features, and then using these chunky entities, you build your system together. So in this OSGi RFC, obviously this concept is not new at all. Eclipse has features, Carafe has features. Years ago, Spring had plans. You know, Sling had provisioning models. I mean, there were lots of different systems out there that did exactly this. And what I think would be great is if we in OSGi can somehow come to a portable format that can work with all of these technologies, so that you have one way of describing this, and then it can work on any of these technologies. So how does this really work in practice? You know, in terms of diagrams, if you want more details, you can look up the talk we did this morning on the internet. But basically, yeah, if you want to build a big system from a lot of fine-grained components, this is kind of not so easy, right? So how do you do this? And feature models or OSGi features are aimed at kind of changing these kind of fine-grained components into more chunky ones, and then with the chunky ones, building a big system is becoming easy. So that's the whole idea there. So if you're more interested, there are details to be found with our previous talk, or otherwise just go to the RFC itself and read up on it there. Okay, and then there is one more RFC that I'd like to go into a little bit more detail about, and that's Typesafe events. So OSGi already has so this is different than the messaging that we talked about before. The messaging that we talked about before was asynchronous inter-VM, inter-framework messaging. Typesafe events are within the same JVM, and obviously many OSGi specs are kind of combinable, so if you want to send these across VMs, maybe we combine this with the messaging RFP that we discussed before. But Typesafe events are about, similar to the concept of the OSGi event admin, sending events within the framework from one entity to another, but now instead of sending plain maps, use typed events, typed objects, so that you don't have to interpret the map and read out what you kind of understand. Rather than that, you get your object as you can use it straight away. So the idea with Typesafe events is that your objects will be OSGi DTOs or similar to OSGi DTOs. OSGi DTOs are also an existing spec that basically says these are data objects, effectively structs in Java. So they can contain primitive types or strings or collections or other DTOs. So you can create your tree of DTOs using this structure. And these DTOs can be put into the event bus and sent to receivers of these events, which are loosely coupled within the same system. So how does this work? It's a bit small, but basically if you want to send events, you look up your event bus from the service registry, the Typesafe event bus. You create your DTO, you know, could be any DTO. You set your fields in the DTO. DTOs are a struct, so you normally set fields directly in them, and then you call the bus to deliver it. You see that there's no topic. You could specify topic on the deliver, but I didn't do that here. By default, the topic is the class name of the DTO. So that's how you send them. And then if you want to consume them, for example, in a declarative services component, could you also use a CDI bean, pretty much the same amount of work. You specify a component, you specify the event type. Now that event type annotation similar to in CDI, will set service property on the service registration. So this component here becomes a service in the service registry, registered under this interface here. Now it's basically a typed interface, so it has a generic type that basically allows you to consume your own DTO type directly. So it's just as simple as this: register the typed event handler with your type, and then your notify callback will be called with the Typesafe event bus when your events are appearing. So this is just a really quick overview. Let's get 2 seconds. A really quick overview of the new specs that we're working on. I know we didn't go that deep, but that's just because of time constraints. If you're interested, get involved. They're all on GitHub. There are 3 others, Dirk, before we get to questions, that I wanted to mention, that we're also working on, what we didn't put in the slides, and these are resource encoding for Java modules. So this one is about representing JPMS modules in the OSGi framework as entities with capabilities and exported packages and so on. So you can use JPMS modules in OSGi and wire to them. There's a 191, which is a microservices architecture. It's more like an umbrella RFP that talks about requirements that need to be satisfied to use OSGi in the best possible way in a Docker or Kubernetes environment. So this actually already points to other RFCs that we're already working on. So most of that is covered, but that's more or less an umbrella document which can be interesting to look at. And then finally, there's also some work going on around actors, using actors in OSGi, but that's not very mature yet, so we didn't really want to spend too much time on it. But you can look at all of these things in the GitHub repository of the OSGi Alliance. And that's it for us. I think we have a few minutes for questions. So Dirk, you already had one.
Yeah, I just have one small question. The Typesafe event handler, bus, whatever, is it synchronous or asynchronous? Because there was only a deliver. So
Yeah, it's always asynchronous.
always asynchronous.
Yes.
Tim's talk today went into it in more depth.
Okay.
Yeah.
So there's another presentation that was given earlier today that goes into more depth on that particular spec.
Okay, that was the one from Tim.
Mm-hmm.
Yeah.
Yes. Yeah. Yeah.
It was, what was it, Event Safe?
Typesafe event. Okay.
Was the name of the,
Okay.
Yeah.
If it's recorded, then I can look it up.
Yeah. So as far as I know, now these RFCs, they're not set in stone, so things might change. But as far as they will,
They will change. They
Yeah.
always do.
Absolutely. But as far as I know, yeah, these events are, at least the delivery part of it is always asynchronous.
I was wondering why the naming of methods changed. Like the one is called notify, which is different to the regular event handler. So you just could copy for simplicity the names used for methods.
That's a good point.
That's a good point. Yeah. I guess no one thought about it. Keeping it the same, or maybe Tim. Yeah. The messaging one. Oh.
The voice messaging RFP. I don't think the requirements state that anywhere.
No.
But so I don't know is the answer. But I think the intention is to make it work well with the Typesafe event
Yes.
work as well.
Yes. Right. Yeah. And then the other comment, general comment is if you go to that Git repository over there, you will also find information on how you can contribute or at least give feedback, which is the minimum contribution. So I think all these things that have been said here now are really valuable contributions for us. So if you have more of them, keep them coming. But you still have 2 minutes to do it now. Wait, 5 minutes. Oh, okay.
Process just opening issues, or is there any other process commenting on the RFCs or RFPs?
It's the basic or the simplest way of providing is opening an issue. Yes. Yes. But if you are more interested, obviously, and then want to influence it more than by just providing information, then obviously the better step is to join the alliance and get involved in the specification process.
Okay, I think that's it. Thank you very much.
Good.